G'day and welcome to part 6 of revising for the specialist exam. Now I've travelled all around Australia, I've read all the past papers, and today I'm going to show you some questions that wouldn't look out of place on a Queensland external paper.
Alright, we're back to Tech Active here from Victoria last year. Give yourself 90 seconds. And I'm going to solve it in 3, 2, 1. Let's do it. Alright, so we've got some sort of soft drink here that's labelled as having a volume of 1.25. Alright. Now, it says that the machine fills them with a volume that is normally distributed with a mean of 1.26 and a standard deviation of 0.01. Alright, that's the population distribution. It is not the distribution of the mean. This is the population distribution. The mean distribution, the distribution of the mean, will be normally distributed as well, and it will have a mean that is equal to the mean of the population, but its standard deviation will be different. The mean's standard deviation will be equal to the population's standard deviation divided by the square root of the sample size. And we're going to fill 6 bottles here. Okay, and we know that the population's standard deviation is 0.01. Alright, so we know our standard deviation because it's that right there. Now we want to know the probability that 6 bottles have a mean volume that is at least 1.25. Alright, so we want to know the probability of bottles being there. Okay, so now we just go to our calculator. Okay, so we're going menu here, we're going probability, we're going distributions, normal CDF or inverse. Normal CDF. Alright, so the lower bound is 1.25, the upper bound is a gajillion, the mean is 1.26, and the standard deviation is 0.01 divided by, I'm just typing it straight into this, divided by the square root of 6. Okay, that should work. And we get an answer of 0.9928. Alright, isn't that nice? We've got an answer here. It's E. Now, the trick here is to note that you're finding the mean and to note that the standard deviation of the mean is not the same as the standard deviation of the population. Next question. Alright, going hard on the stats here. Give yourself 90 seconds. And I'm going to solve it in 3, 2, 1, let's go. Alright, so I've dived into my formula sheet and found this confidence interval thing. Now, what do I know? I've got 36 things in my sample, so I know N, that's good news. I'm doing a 95% confidence interval, so I know Z is 1.96 or 1.9599, I think. What I don't know is this standard deviation here. So, this bit here of my formula is my margin of error. My margin of error. Now my margin of error is equal to the difference between this and this divided by 2. And that's equal to 4.445. So what have I found there? I've found this value in the box. Now we don't need to find the mean here. We could find it, right? We could add these two together and divide them by 2, and that would give me my mean. But I don't need the mean because all the information I need is within this box. So, now that I know that the margin of error is 4.445, that's going to be equal to the z-score, which is 1.96, times the standard deviation, which I don't know, divided by the square root of 36. Rearranging 4.445 divided by 1.96 and then multiplied by the square root of 36, which is 6. And that is going to be equal to my standard deviation. Alright, so my answer is 13.607. I need to round, and just round appropriately. So 13.61. My answer is D. Okay, moving on. Alright, 10 marks from Western Australia in 2016. So give yourself about 15 minutes, and then I'll come back. Alright, I'm solving this in 3, 2, 1, let's go. Alright, so my first step is to show that the volume of water is equal to 4h squared. where h is the height of the water at any given time. Alright, so I know that the volume of the water would be equal to the area of that multiplied by the length of our thing, right? So let's just write area times length, and we know that the length is 4. Alright, so volume equals, I guess, 4A, and I need to find the area of this red thing that I just coloured in. Alright, how am I going to do that? Well, I can see it's a triangle, so it's got a height of h, that's a h there, and then let's call this bit x, right, because I can deal with that. Now I've cut the triangle in half to make like a right angle, and I've got a 45-degree angle right there. So now I'm just doing some trigonometry, right? So tan 45 equals opposite over adjacent, so x over h. We know that tan 45 equals 1, so 1 equals x over h, and handily x equals h. Okay, so now that I know that x equals h, if I want to find the area of that entire triangle, I can say that the area of a triangle, 4 is the depth, the thing I'm multiplying it by. The area of the triangle is going to be equal to the base of the triangle, which is 2x, times the height of the triangle, which is h. But there's too many variables here. I know from my work that x is equal to h, so let's get rid of that x and put a h there. And then, because it's a triangle, we divide by 2. Base times height divided by 2. So those 2's cancel out. H times h is h squared. We get 4h squared. So the volume with respect to height is equal to 4h squared. We have done part A. Alright, so part B is determine the rate of change of the depth. And depth is measured as h, right? So we're looking for the change in h with respect to time. Now, you can tell this is a related rates question, right? So I like to set this up nice and early, dh, dt. If I'm wrong, I'll just backtrack. Now, what's the other variable here? It's clearly volume. So dv, dv. Okay, so what do I have? Well, I have a relationship between v and h, right? So the change in v with respect to h, so let's write it here, v equals 4h squared. So the change in volume with respect to h is equal to 8h, which means that the change in h with respect to v is equal to 1 on 8h. Alright, so I have a dh dv, 1 on 8h. And I need to multiply that by the change in volume with respect to time. Okay, the change in volume with respect to time. I was a bit worried there for a second, but you can see it's sitting right here. Loses water at a constant rate of 0.08 cubic meters per hour. So the change in volume with respect to time is 0.08. So what do I have here? I have 0.08 over 8h. I should be able to simplify that. Maybe I'll shove it in my calculator. Now my answer is currently 1 over 100h. I'm wrong. It's wrong. I'm going to go one more step though before we confirm that I'm wrong. But 1 over 100h so far. We need to know at what rate is it changing when the depth is 0.6. So let's sub in 0.6 for h. Remember, I'm wrong. It's not working. 1 over 100 times 0.6, and my answer there is 0.02. My answer there is 0.0166666. The question asks me to round to the nearest 0.01, so rounding that I get 0.02. And what are the units there? It's meters per hour. Okay, I'm wrong. It's wrong. Have you figured out why it's wrong? Determine the rate of change of the depth. This says that the height is changing at 0.02 meters per hour. But if the height is changing at 0.02 meters per hour, that means the height is rising. This thing's filling up with water. It's not going down. So, what did I stuff up? It says that the volume with respect to time is changing at 0.08, but it's decreasing, it's leaving. So we needed a negative right here, which gives us a negative 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 here. Related rates, you're going to stuff up this negative positive thing, or at least I do, so make sure that at the end you check that it's making sense. Alright, part C. Whoops, kind of feels like I just did that, because I just proved that dH dt is equal to negative 1 on 100, so you wouldn't do this in exam, but like, come on, see above. Okay, how did this happen? How have I gotten this question here where I've solved before I've gotten to the section where I'm supposed to solve? Well, I guess I could have solved this a little bit differently. Here, 1 on 8h times negative 0.08, that right here, right there, let's go with a different colour, right here, I could have subbed in that 0.6 for h. I didn't need to simplify and make it into this thing. That's just force of habit, I guess. So that bit could have happened up there, which would have led me to this answer, and skipped over that answer. So in any case, there we go. All right, done. So now that we know that dH dt equals negative 1 on 100h, we can find a relationship between h and t. All right, so the integral of 100h dh equals the integral of negative 1 dt. All right, so the integral of negative 1 is negative t plus a little c value on here. And the integral of 100h is h squared and then 100 divided by that 250h squared. Now I can put a little plus c in there, but then the plus c's and the plus c's, they're arbitrary constants. They smush together and you get another arbitrary constant. So we just need one on one side. All right, what do I want? This is a relationship between h and t. What else do we want, I guess? I probably need to figure out what that c value is, though. To figure out that c, I need some sort of initial value maybe for h and for t, or at least something that tells me when h was this, t was this. So searching. Okay, initially the tank is completely full. All right, so that means that initially the tank's all the way up to the top, which means that initially h was all the way up to there. All right, and I can find that easily enough, right? I've got 1, and I should be able to find that length. So similar to what we did before when we wanted to find that x value, we've got a h all the way up to the top. Sine 45 is equal to opposite over hypotenuse, where the hypotenuse is 1. All right, so that means that h is equal to sine 45, which is 1 on root 2, or root 2 on 2, whatever you want. So if we put it into here, we'll get 50, 1 on root 2 squared, equals time t is 0, this was the initial time, is equal to c. So c is equal to whatever that is, which is 50 over 2, so c is equal to 25. So it's really all over now. We've got 50h squared equals negative t plus 25. Now, I don't know how to interpret this question. It says, hence determine the relationship for the depth h and any time t hours. This is a relationship between h and t, but maybe it's not the expression for h. So let's just go one step further and say that h squared is equal to negative 1/50th t plus 1/2. And then h is equal to the square root of negative 1/50th t plus 1/2. Okay, I feel pretty good about that. If you're screaming about positive, negative there, the h can't be negative, so I can omit the negative there and keep h as a positive value, which makes sense here. Alright, just made the effort to get it all on one page there. Is this scribbling? Is it required in here? I don't know, maybe, but it's very small stuff. Okay, last question. Alright, hello Tasmania, 2021. Give yourself about, what have we got, 6, 7, 8? Give yourself about 12 minutes to get this done. Similar skills to last time, but different. Okay, I'm going to solve it in 3, 2, 1. Let's go. If you're not careful, you might get confused because it says initially, and so initially you're thinking times 0, and you're trying to sub in t equals 0. But you don't have to do that because it says there are initially 10 pairs of cockatoos. So we can sub in 10 for n here as our initial number. Alright, so dn dt equals 10 over 180, 100 minus 10. So we've got 90 times 10 is 900. 900 over 180. This is tech active, but I'm feeling good. 5. Okay, that's question 1 done. It's only worth 1 mark. Okay, interpret what happens as n approaches 100. Let's see what happens if I sub 100 in here. So dn dt equals 100 over 180 times 100 minus 100. So if I sub 100 in here, the rate of change of the cockatoos is equal to 0. Now, that won't happen because the rate of increase is slowing. So this is like a limits thing. The limit as n approaches 100 for the rate of change is equal to 0. Alright, so that's the carrying capacity of this place. That's as many cockatoos as we can have here. This is probably an okay answer. The rate of change slows towards 0, therefore the population of 100 pairs is a maximum. 1 mark. Okay, so I've got to say this next bit is like my least favourite thing to do possibly in all of Specialist. So let's go ahead. We've got dn dt equals n over 180, 100 minus n. Write it down. I'm going to rearrange this to get all the dn stuff on one side and all the dt stuff on the other side and take the integral of both sides. Now that right-hand side looks lovely, so we're just going to say 1 on 180t plus some unknown c value. But it's this left-hand side that's annoying, so we're going to forget integrals for now, and we're going to focus on that fraction right over here. Now we're in partial fraction land, so we know that this can be written as a partial fraction, a on n plus b on 100 minus n. Now we can put both of those fractions over the same denominator by multiplying a by this and b by this. Now this of course means that 1 over n 100 minus n and this over n 100 minus n. So therefore 1 is equal to a 100 minus n plus b n. Okay, now we need to figure out what a and b are. So we need to choose some clever values for n that will reveal what a and b are. So let n equal 0. If I let n equal 0, that bn is going to disappear because b times 0 is 0. So I'll end up with 1 equals a times 100 minus 0. A is equal to 1 over 100. Okay, choose another clever value. If I let n equal 100, I'll have 1 equals a times 100 minus 100, which is a times 0, so the a goes away. 1 equals bn, where n is 100, so 100b. And what do you know? b is equal to 1 over 100. Okay, we can finally finish off. Therefore, 1 over n 100 minus n is equal to, now the a is equal to 1 over 100 over n, plus the b is equal to 1 over 100 over 100 minus n. We can bring 1 over 100 out the front here, multiplied by 1 over n plus 1 over 100 minus n. Whew, that's quite the detour. Now we can take this back way over to here. Now I can be a bit clever here because I've got this 1 over 100 out the front of that, and I'm finding the integral of it. I can put the 1 over 100 out the front of the integral, and now I'm finding the integral of 1 over n plus 1 over 100 minus n with respect to n. Okay, so we've got 1 over 100, and the integral of 1 over n is ln n, plus the integral of 1 over 100 minus n. You've got to be a bit careful here. A lot of people are going to get excited and say that it's ln 100 minus n. But, see this negative n here? We've got to bring that out the front as 1 over negative 1. We're bringing the derivative of whatever's in our ln out the front, or our a value in the form of ax plus b. We're bringing that out. So, all that has the effect of changing that plus to a negative. 1 over 100, blah, 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 blah. Now, there is a plus c there, but because there's a plus c and a plus c, and they're both arbitrary constants, we can stay with just the 1 plus c. Okay, that's a pretty good start, but we're a long way from determining n with respect, or nt. So let's do a few things at once here. I can multiply both sides by 100. If I do that, I get rid of this 1 over 100 here, and I get 100 over 180 here. And I can multiply c by 100, but it's an arbitrary constant, so now it's just a different arbitrary constant. So I've got that plus c. And 100 over 180 is 10 over 18, which is 5 over 9. Alright, so let's call that 5 over 9. And now I've got this stuff here, ln n minus ln 100 minus n. Log laws, we've got ln n over 100 minus n. Okay, this isn't feeling too bad at the moment. What can I do from here? Well, I really want to know what that c value is, right? Luckily, way back when, I found out that initially there were 10. So, at times 0, 10. So let's sub that in. N equals 10 when t equals 0. I get something that looks like this. Now 5 over 9 times 0 is 0, so that leaves my right hand side with just c. And ln 10 over 100 minus 10 is 10 over 90, which is 1 over 9. So we get ln 1 over 9 as our c value. Now that we've got that, let's put that ln 1 over 9 back into our equation. That gives us this line here. Now I've got a 5 on 9t and I've got another ln. Maybe I should group the ln's. Of course, now that I've grouped my ln's, I should use a log law to simplify them. Of course, writing it as this stacked fraction is ridiculous, so let's fix that. Now we're never going to get this as n equals something while it remains in the log. So let's write this in exponential form. So this is okay, but if I reversed everything, that's a bit better, because on the right hand side I can write it as 100 over 9n, and on the 100 over 9n minus n over 9n. Now n over 9n is just 1 on 9, and it's probably easier rather than having fractions and e's and all the sorts of things, but I just write it as e to the negative 5 on 9t. Okay, it's all over bar the shouting now, because I've got e to the negative 5 on 9t plus 1/9 equals 100 on 9n. I can now move that 9, or just n maybe, up to here. And that'll give me 100 over 9, and move all of this down to here. 9 times e to the negative 5 on 9t plus 1/9. And I guess it would be neat if I expanded that bracket down the bottom. 100 over 9e to the negative 5 on 9t plus 1. N equals that. I am done. Alright, so this is all the main working for it. You can see this partial fractions bit here. I'm looking forward to all the people in the comments telling me how I could have done this like 10 lines faster. So if you do, make sure you explain it to us. But we got there in the end. Part D. Alright, so last question. After how many years does a population reach 90% of its maximum? Well, we know that the maximum is 100, so 90% of that is 90. So n equals 90. we sub that in. And given I have my calculator, I'm out of patience. Let's end solve that. Alright, end solving it, we get 7.91. So don't get cute with this. After how many years? After 7.91 years. That's the answer. Don't feel like you have to round to 8 or round down to 7 or something like that. There's such a thing as half a year or 0.9 of a year. So we can do that. Alright, well that was a fun one. I like that. Let's tick off some questions. Alright, so 2 tech active multiple choices, 2 tech active short responses, and that's it. Alright, so it's all well and good to see me doing it, but obviously now you've got to go away and think, could I have done that? And is there some other questions that I need to practice? Have fun.